going to talk about sum and difference of two cubes. We need to know first what we mean by perfect cube. We'll underline 2 and put binomial there, and that just simply means it's going to have two terms in it, and it can be a sum or a difference, and that all comes back to the idea that you can take the cube root of negative numbers. You can't take the square root of negative numbers in the real number system. We can do square root of negative numbers, but not under our normal number system. So let's talk about, we talked about perfect squares the other day. Let's talk about what perfect cubes are. Now, the easiest way to find those, and they get really big really fast, so we stay with the smaller numbers. I can show you how to do cube root on your calculator, but the ones I'm going to give you will be the ones, really all the ones you need. I'm going to give you one you probably won't see with me, but it's an easy one. And the best way to find them is like 1 cubed. And if you remember, I said to you the other day, 1 is actually a perfect everything. Perfect cube, perfect fourth, because the square root of 1 is 1, the cube root of 1 is 1, so 1 cubed is 1. And then 2 cubed is 8. Now let me show you the notation. So where we normally, and a lot of times there's like a little extra space right there, when there's nothing there, that would mean square root, but it's understood. It's like an understood 1 in front of an x. But when it's something other than square root, that's where the root goes. And so the cube root of 8 would be 2. That's the notation of it. But you also, and I'll go ahead and address that right here, you can also take the cube root of negative numbers, because, now if you write it like this, you have to put parentheses around it, equals -2 times -2 times -2. That's the only way I wrote it in the second block, and that's -8. The 3 numbers multiplied together give you the -8, so it's kind of interesting. 3 cubed is 27. You need to know those 3. 4 cubed is kind of also a special one, because look, it's a perfect square and a perfect cube, and if I get a chance, I'll show you one that sometimes they throw at you and you're like, you know, is it a perfect square? Is it a perfect cube? It's both, and you kind of have to take it in the context of the problem. X squared minus 64, x cubed minus 64. Which way would you treat it? And then 5 cubed is 125. 6 cubed, and I don't even know if I went that high on them on classwork, but I'll put that one. Those are about as far as I recognize them. And then I am going to put ... and put 10 cubed, because that one is one you might see, and it's a pretty easy one. The cube root of 1,000 is 10. Variables, we're only dealing with the cube root of x cubed. So x cubed is a perfect cube. But, and that's the one we're using today, but you may see x to the 6. Now another thing you run into also is x to the 6 is like 64. It's a perfect cube and a perfect square. But the cube root is x squared, because, remember, you add their exponents, x squared times x squared times x squared would be x to the 6. Start with the sum. So I'll do x cubed, actually I'm going to move that down, because I'm going to write some stuff under it, over it. So that would be considered the sum of 2 cubes. And it factors into a binomial and a trinomial. Terms binomial, 3 terms trinomial. When you do the difference of 2 squares, the first thing you had to do was take the square root of both of the terms. So a difference of sum of 2 cubes is going to be cube root of that one, which is x, the cube root of this one, and then we'll go ahead and start talking about the signs, and those number, whatever that sign is going to be the same. So the rules for sum of 2 cubes and difference of 2 cubes are actually very similar. They're the same terms, the signs are just going to be different. Now here's the interesting part. When you go to do the trinomial, you don't look back at the original problem anymore. You're actually through with that. What's going to help you get this over here is going to be these 2 things. So the first thing you're going to do is take that one and you're going to square it. And x times x is x squared. And the middle term, and I don't know how to do this other than just kind of, I did kind of a little squiggle right here, is going to be multiply those 2 terms together. So x times y would be xy right here. Y will determine the last term, and you're going to square it. So it would be y squared. This one will always be a positive because, let me write the word instead of that. I'm going to say always positive. Because you're squaring a positive, or you would be squaring a negative, and that's always a positive. Now this one, these two, or whether you consider it from here, I say just look at these, is going to be opposite. So these two will be opposites. We're going to do the same thing with the subtraction, and the only difference is going to be the signs. So I'm not going to write all of that again. Now, if you want to check it, it's not fooling because it's a binomial times a trinomial. You would have to take the x and distribute it all three of those, 3 terms. Take the y, distribute it. You'd have 6 terms, and all this stuff will add out except the first term and the last term. These are the 2 terms that are left. The x times x squared gives you that one, and the y times y squared term gives you that one. And that's the 2 terms, and everything else adds out. You know, positive this and negative this adds out. So the first binomial is cube root, same sign, cube root. Okay. I think that's the only thing I wrote on this one. Same sign. Now, cover that up. We'll go over here. We'll square that one. We'll multiply them together, and we'll square the last one. This one is always positive, and this one is the opposite of that one. Now, that's your rules. And to me, once you learn the numbers or the terms, the signs kind of fall into place. Let's do 3. Top of page 43. Kind of rearranged up here, and I ended up with a little bit more room of trying to keep things on screen. Number 1, 27m cubed minus 8. You know, it's always a good idea to check for GCFs. The GCF of this one is 1, because I think you have a few that the GCF is going to be important. So, got a binomial, a trinomial. The cube root of 27m cubed will be 3m. Sign will be the same, so we'll go ahead and put the minus. And the cube root is 8 is, and I'm going to actually approach that a little bit different when I do the next ones. And then the cube root of 8 is 2. Now, you got to get those right, because the rest of it depends on, if you miss those, you miss all of it, it's pretty much a -4 on a 5-point problem. Now, ignore that. First term, you're going to square it. So what's 3m times 3m? 9m squared. And then remember, these 2 signs are opposite, which will make that a plus. You multiply the 3m and the 2, and you get 6m. And then you square the last one, which would be +4. And if you try to factor that, it will not factor. It is prime. It is, the GCF of this is 1, GCF of that is 1, and that is not a trinomial that will factor like you've been doing. Number 2, 125 plus 27a cubed. And it's hard to give you many different numbers because I just don't like to get up into the big, 8 cubed and 27 cubed and all that. So you will have ones that you shouldn't have too much trouble with the numbers, and we'll do a cubed there. Even though you could commute that and put the a cubed at the front, I would not commute it. I would leave it just like it is. Treat it same way. So, binomial, trinomial. Cube root of 1, I tell you, now this is me. This is me. Here's what I'm going to do first. Positive problem, so I'm going to go ahead and put my plus there. These 2 are opposite, and this one's always a plus. Now, if you can do that first, that will make your life a whole lot easier, I think. So, what's the cube root of 125? 5. Cube root of 27a cubed. 3a. Okay, square 5, you get 25. Multiply them together, you get 15a. Square that one, 3a times 3a is 9a squared. That's why we did that lesson 12. Was it 12? That was the laws of exponents. first. I made the mistake of that last year, of putting that later. I don't know really why I did that. I wrote myself a note. Don't do that again. Number 3, 16m cubed plus 250 n cubed. M cubed, n cubed. Okay. Now when I look at it, 16 is a perfect square. We're doing cubes. It's not a perfect cube. 250 is not a perfect cube. And where that gets a little crazy, if one of those had been a 64, and you're like, well, I can take the cube root of it. Does it have, but see if you have a GCF. They don't have a variable like, but I think you can take out a 2. And you have 2 times 8x cubed, we like that much better, and 125 n cubed. And then I'm going to bring the 2 down. That's part of the factor tree. Now, do you like doing signs first? To me, it's easier. I say it's a plus problem, opposite, and the last one's always a plus. Now, that's me. That's just the way I do it. Cube root of 8m cubed. 2m and 125 n cubed. 5n. Does that make sense? Okay. 2m squared, 2m times 2m is 4m squared. 2m times 5n is 10mn. And then 5n squared is 25n squared. And it's really weird. The most miss a lot of times is the variables. They won't square it, or I don't know, they might put 5n squared. There's just some kind of weird stuff with those first and last terms. That's it.